Welcome to the tutorial PowerXL DC1 or DB1 frequency inverter commissioning a permanent magnet motor. This tutorial shows how to commission an exemplary permanent magnet motor on a PowerXL DC1 or DB1 frequency inverter. The following technical requirements must be met for this: a DC1 or DB1 variable frequency drive, a node. The DB1 frequency inverter has no heatsink compared to the DC1. Here the existing possibility of cooling within the custom application is used. In the parameter settings related to the connection of a PM motor, there is no difference between DC1 and DB1. A DX-CBL-PC3M0 serial programming cable or a DX-COM-Stick3 Bluetooth communication stick for easy parameterization of the device. A note: on the DC1, the integrated keypad can also be used to make the necessary parameter settings. The DB1 does not have an integrated keypad due to its compact design and the intended applications. Via an external keypad DX Key LED 2 or DX OLED with plain text display, parameterization is also possible. The programming software Drives Connect or Drives Connect mobile app. No license is required for the Drives Connect programming software or Drives Connect mobile app. The software for the PC can be downloaded from www.eaton.com/software or for a smartphone from the App Store or Play Store. The motor datasheet of the PM motor to be used. The motor data are provided by the manufacturers in different forms. In the displayed application node AP0463EN, operation of PM and brushless DC motors, the necessary parameter settings for the DC1 are given for an exemplary motor. In the PM motor used there, the following shown data are available from the motor manufacturer. When setting the motor parameter P07, motor nom voltage, in the DC1, it is important to set the value of the back EMF calculated for the rated speed, not the rated voltage. In this application, this results in a calculated value of UP1000, 215 volt, multiplies with 1500 divided by 1000 equal 323 volt, rounded up from 322.5 volt at 1500 RPM. For the configuration of the frequency inverter, the software Drives Connect is used in this tutorial. There are two ways to perform the parameterization. In real-time mode, where each parameter is changed directly in the DC1. In offline mode, where all parameters are changed first and then transmitted as a whole. In the following, the offline parameterization is selected. As a default setting, the 7.5 kW DC1 34018FB -820 CE1 was stored here as the default drive descriptor, which is documented here in the drive description. In the parameter editor, the password P14 is set to 201 for the necessary access to all parameters. Automatically, the groups extended and monitor appear. The motor parameters P07 to P10 are set. As mentioned before, not the rated voltage, but the calculated value for the back EMF, here 323 volt, is entered in P07. In P08, the maximum rated device current of 18 amps can be entered. Here the rated current of the PM motor of 14.2 amp is entered. The default setting of P09, motor nom frequency, is used. As soon as the necessary setting of P10, motor nom speed, is made, all parameters with unit hertz change to unit RPM. A tip: if there are desired values in hertz, for example the fixed frequencies, these values should be made before changing P10. After this action with input of the value for P10, the correct value for the fixed frequency in RPM is automatically given in the background, taking into account the entered value for the motor nom frequency P09. In the extended menu, the switching frequency P17 must be set to at least 16 kHz for optimum operation of a connected PM motor. Before the motor identification can be started, the motor control mode P60 must be pre-selected to PM motor speed control in the next step. A note: if there is a motor choke DV to DT filter, sine filter or all-pole sine filter between DC1 and PM motor, it must be bridged for correct motor model identification in DC1. For the serial communication via DXCBL PC3M0 with the DC1, the wired serial interface RS485 has to be selected as connection type via Tools, Select Communication Device, here via the USB port COM5. Then press the Connect button. The selected communication device is displayed at the bottom left. The parameters changed to date are then transferred to the selected drive via the Transfer Parameter Set to Selected Drive button. The progress of the transfer is displayed at the bottom right of the Drives Connect. Likewise, the successful parameter transfer is confirmed in the display of the DC1 with the message Pass T. For control purposes, the drive network is now scanned. For the next step, it is mandatory to disable the real-time edit mode. The motor identification can only be activated with the DC1 via the keypad. The preset data logger with trigger on event mode for a higher resolution visualizes the process of the motor identification run. The value 1 is now specified via the keypad in P61 using the up arrow key and acknowledge with OK. Note: if a motor is connected to the output of the DC1, the motor identification run is performed directly at standstill when the OK key is pressed. No further enable is required here. The motor identification process takes approximately 5 seconds in this case. If no motor is connected, the error message ATF01 is displayed. Other possible error messages during the motor identification run are shown. After successful motor identification, the new values from P64 to P66 for the internal motor model can be transferred from the DC1 variable frequency drive to the Drives Connect software. A note: the measured values for the internal motor model of the DC1 do not have to match the specified values from the motor manufacturer's datasheet. The optimization of a DC1 or DB1 to a PM motor is shown in the following video. PowerXL DC1 or DB1 frequency inverter optimizing a permanent magnet motor is covered. Thank you for your attention.